Hello and welcome to this Unit 5 test review. Let's get right into things. Number 1, a method is named setHeight. What is its return type likely to be? And if you're setting an instance variable, you don't have to give any information back, so it's most likely to be void. Now occasionally you'll see a set method that's Boolean, and that's because it will either say true, I was successful in my task of changing this instance variable, or false, I was unsuccessful. You gave me like a invalid value or some other reason that it couldn't do it. Number 2, it is considered good programming practice to set instance variables and static variables to private and only give methods to allow options to change them. And that is an example of encapsulation. Abstraction is hiding how you do things, and encapsulation is hiding the state of your data. Number 3, which call to this method is written properly? Well, immediately I see this is a static method, and any static method cannot be used in conjunction with a variable. So when I say, bar.foo, that shouldn't work because bar is the name of a variable, and you can't use the name of a variable in conjunction with a static method. So it would have to be either A or B, the name of the class, and then the name of the method. So which one should it be? Well, this is a void method, which means it's not giving anything back. So to say equals with a void method doesn't make any sense. It's like this integer x, it's going to be equal to the value that I get from foo.foo, but that doesn't give any information back. So you're trying to save nothing into something, and that doesn't work. So the correct answer is B. Number 4, a method accepts a single parameter, checks to see if that parameter falls within a range of acceptable values, and then modifies an instance variable. So anything that modifies an instance variable, just immediately right there, that is going to be a mutator method. Mutator means to change, or mutate means to change, I should say. And that's the definition of a mutator method. Now, this part is optional. Of course, a mutator method could just set a value and forget it, no big deal. But oftentimes you'll see that you only want to change a variable if it's a valid value. For instance, a mutator method might disallow negative numbers for certain things like age or something like that. Number 5, which of the variables can be called directly only after creating an object of type foo? So the class is of type foo, and we can assume that there's constructors in there that can be made. And we have these two variables. One of them is a static variable, and one of them is a non-static variable. This one would be referred to as an instance variable, and the first one would be referred to as a static variable. And we want the one that's only usable with the object, and that would be the non-static. So that would be option B, variable y only. Number 6, a class has instance variables named shape and color. And then a method in that class accepts parameters named shape and shape color if the method intends to access the instance variables, which would require the program to use the this keyword. So you can use the this keyword to access instance variables anytime. Doesn't matter if you have parameters that match that name or not. If you say this, the computer knows you are trying to access an instance or a static variable. You are required to use this keyword if you have a matching name, and shape was the only one that had the matching name, so the correct answer would be A. Moving on, number 7. There are 2 ways to change the value of this static variable during runtime. What are they? So one of them is, well, this is a public variable, so we can just say test.num equals. Another way is we have this public method called setNum. So that also changes the value of num. And so those are the 2 ways. We can either say test.num equals or whatever, or we can say test.setNum and then supply some value that will be sent in the parameters. And I actually have this one right here. Well, let me open up the code first. And whoop, it went onto the different screen. And so we have this here. We have a public static int num, and then our set num method. And so if I were to say test.num equals 5, and then print out test.num, and then say test.setNum, use the method and set it to -7, and then print it out again, I'm expecting it to print out 5 and then -7. So let's go ahead and run it and see what happens. And once again, it opened on the other screen. There we go, 5 and then -7. So you can either say access the variable directly by saying the class name and then the variable name, or you can change it using the setNum method. So both ways work. Moving on. All right, so number 8, write a method call to the math class that calculates the cosine of 3 pi over 4. So sure, we need to use the math class, and if you don't know the method call, you go to the math class and you look up the cosine calculation method call, and it's called .cos, C-O-S. And I believe, yep, here we go. I have this as well. And so if I want to write the cosine of 3 pi over 4, whoops, what just happened? Sorry, boomer moment. If I want to write the cosine of 3 pi over 4, then I would have to say math.cosine. And then next challenge is, well, wait a second, how do I get pi? And once again, that would be math.pi, capital P, capital I, because that is a constant and it's considered standard notation to write constants with capital letters. So there's pi, but I want 3 pi over 4, so times 3 divided by 4. And note the spaces are not necessary, just there for visibility. And so I have the cosine of pi, but times 3 divided by 4, in other words, cosine of 3 pi over 4. And let me just press compile to show you it is compiling. That's the correct method call. Moving on. Number 9. Write a class definition with a constructor that will create an object with the following constructor call. So we basically want this constructor to work. And that means we need to have a class of type dog, all right? And that class needs to have a constructor that accepts 3 things, right? 1, 2, 3. Oh, these can be whatever you want them to be, but it must be a string, and an int or a double. So I have this one as well. This is the call that we want to make right now. I don't have that implemented, and so it's going to say, hey, that's not going to work, which is why I have my dog class here. And let me go ahead and copy paste this over so I can have it for reference. That's the constructor that we want to work, the constructor call, I should say. And so let's think. Brutus sounds like a name to me, so I'm going to say string name, right? This is an instance variable, so let's make it private string name. Brown, definitely, okay, that's a color. So private string color. And then 105, this could be, whatever. Maybe it's age in dog years, maybe it's weight, maybe it's height or length or something like that, or in, I don't know, centimeters, whatever. It can be whatever you want it to be. Let's say that this is age. This is a very old dog. And so private int age. So those are my 3 instance variables. Now to make my constructor. To make a constructor, I simply say public, because otherwise it would be a useless constructor. Dog to match the name of the class. And then these 3 values. I want the name, the color, and the age in that order. So string name, string color, and int age. Okay, and if that's true, there's one last thing that I need to do. I need to get the values that are in these parameters into my instance variables. And so, again, we talked about this before. If I want to access the instance variable, I say this.name, and I want that to have the same value as my parameter, this dot name equals name. This dot color equals color. Oops. And this dot age equals age. And with that, I press compile. Let's go back to, oops, let me close this old code, to question 9 here and see if that now compiles. Sometimes it takes a minute. Sometimes we have to go all the way back here. Let's see, what is it not like? Oh, this is actually something that can mess you up. If you are copying code from Word and you use quotes, it's actually going to mess you up because there's more than one type of quote, and the type of quote that Java is expecting is not the type of quote that that Word puts into its documents. And so this is really, really weird. But notice that if I delete this and I get rid of it, now it's in green, and that's our clue that, yeah, that's what we want here. So let's try that. It still doesn't like it. Did I forget something? Illegal character. Let's see. Is it talking about this? Let's try that. There we go. So that's, hey, unintended lesson here. When you copy code from Word or other text editors, sometimes they use symbols that look the same, but actually are slightly different codes, and so it's not what it's expecting to see, and it gives you an error. And so we can see that it now compiles, and so everything should be working. Nice. All right, moving on. We got question number 10. I did finish that, right? Oh, yeah. Yep. Oh, I even said, assume that this is an int. Okay, cool. So we want to write an accessor method for one of the instance variables that we created in question 9. So we're going to go back here, and if it's an accessor method, that actually has to be in the dog class, which means I'm going back to dog, and let's say that we want an accessor method for name. Doesn't matter. So if it's an accessor, it gets the it's a getter method, right? It gets the name and it gives that back. Name is a string, and accessor methods typically are called get and then the name of the instance variable that you want to return. So let's get the name. We don't need any information in a parameter. We're giving information, but we're not getting any information. Getter methods don't work like that. And let's return name. So there we go. That is our accessor method done. Next question. We want to write a mutator method, and this is specifically for the int instance variable. So ours is going to be, at least my version of this, is going to be age. And we want to determine what an illegal value would be and only update it if it's a legal value. Okay, so an illegal value for age, I think I already said that in this very video, would be a negative value. You can't be negative years old. So I'm going to go to my code, and let's make a mutator. This one would be public void. Again, could be Boolean. You could say, yes, I was successful, so I'm going to return true. You don't need to, though. So public void, whoops, set name, set age, excuse me, had to be the int one. And this time we need parameters. We need to say, well, what do you want the age to be? I can't set the age unless you tell me. So tell me the age, and I'm going to have that in here. Maybe I'll call it new age. And like I said, I'm only going to allow this if this is a non-negative. I mean, I could even argue don't allow 0, right? But whatever, I'll allow it. Non-negatives, I'm going to say that's an illegal value. And so if, and only if, this is a positive value, I will update the age. So if new age is greater than 0, then age equals new age. And this is an example of we don't have matching names. Like my instance variable is called age and my parameter is called new age. So I don't need to say this, but if I did, it would totally work. Not a big deal. So if you want to be safe, just always say this and build that habit. And that way you'll never forget, right? Never hurts. So that's how we would do an accessor, excuse me, a mutator method with a quick check in there to make sure that it's a legal value. Okay, cool. Next up, we got number 12. Write the code to fill in this method below. And honestly, we've already talked about this. Like I have a little program here, question 12. I'm not sure we really need it because all we got to do is say, well, we have matching names, width and height. And so all we have to do is say this dot width equals width, this dot height equals height. And that gets, again, the instance variable width to match the parameter width, the instance variable height to match the parameter height. Cool, whatever. We could put in a little if statement that say only do this if it's a positive number. Really, even 0 doesn't really work for shapes because like a length of 0, all of a sudden a rectangle just turns into like a line. Like if you have a height, well, I guess that goes this way. If you have a height but not a width, it's just a line. So you could argue it can't be 0 either. But either way, as long as you said this dot, that's what I was really looking for. Okay, number 13. Write a method that we could add to the math class that calculates the next step of the hailstone number process, which is, of course, if it's even, divide it by 2. If it's odd, multiply it by 3, and then add 1. All right, cool. I have that here. This is my, math class. A chance to show you what these would look like in the real math class. We say public, and this is one of those rare cases where we, oh, I actually forgot a keyword in here, public static, there we go. In the real math class, yeah, pi and e, those are public variables, and the reason is because they are final, they are locked into their values, you can't change them. So public static final double pi and e, those are just assigned values, and whatever, they can't be changed anyways, so it's totally fine to make them public. That being said, here is my hailstone process, and the key thing on this is that it had to be a static method, because every method in the math class is static. And even the constructor is, well, even the constructor, what am I talking about? The constructor is not static, but the constructor is private. So you actually can't make a math object, which means there's no reason to have any non-static methods, because non-static methods only work with objects. And so if you can't have one, hello. So the key was that this needed to be a static method. And it should be returning an int, because if I give you an int, then, in the hailstone process, it only works with integers. And here's what I think would probably be the fastest code to do this. If the value mod 2 is 0, return the value divided by 2. I don't even need to say else, because there's only these two options. And the only other thing that could happen is that I return. So I don't even need to say else. If I said else, that would work. But just, saves one line of code, whatever. So this is a simple hailstone process, Cool. And that brings us to, I believe, our last couple questions here. Yeah. So which variables are in scope labeled here? Okay. Well, A is an instance variable, which means it's in scope in the entire, in the entire class. Everywhere between these squiggly brackets, or braces as they're technically called, I think, A is in scope. So anywhere where I said A, it would work. B is in scope only in this constructor. It is a parameter, and parameters only exist within the method that they are made. And for that is this constructor. So I say B here, and that's fine. That is within this same constructor, and that's where B exists. Same deal with C. That exists everywhere inside of this method. And so if I say C, yeah, all good. And then finally D. D is created specifically to make this for loop work. Oftentimes we say I, this time this one says D. Whatever, no big deal. And here is after the for loop, which means D is not in scope. D only exists in that for loop. B is not in scope. That only exists in the constructor. A and C, however, are in scope. A exists everywhere, and C exists everywhere in this method. And here is both in that method and in that class, therefore A and C exist there. And would the code compile? Yes, it would. So A and B are the only variables mentioned here. In my for loop, I mentioned D, A, and that's it. So yeah, that would work too. If I had said B here, that would not have worked because B would have been out of scope and it would not have run. 15. Which method in this class can be called without involving an instance of the class? So again, this is just a fancy way of saying which of these is static, and gee, I wonder. So the correct answer is get area formula, and that's because it's static, and static methods mean that they don't involve instances of the class. They do not involve objects. All right, so that's it. Hope that was helpful. Thank you for watching, and I will see you again next time. Bye-bye.